In the past, we've talked about congruence. We say that congruence means that things have the same measure, they're equal. So congruent segments are segments that have the same length, and congruent angles are angles that have the same angle measure in terms of degrees. When we want to talk about congruent polygons or congruent triangles, those polygons or triangles have this congruent corresponding sides and corresponding angles. So when you name them, you have to list the corresponding vertices in order. In this example, we have two congruent trapezoids. So in order to list the sides that are congruent to each other and the angles that are congruent to each other, we have to notice a few things. First of all, this segment BC has a single tick mark. That single tick mark notes that it is the same length as segment XY. So listing congruent segments, segment BC is congruent to segment XY or YX. Likewise, two tick marks signify that segment AB is congruent to segment XW because they both have two tick marks. To show that segment AD is congruent to segment WZ, the three tick marks denote that those two are congruent to each other, but not necessarily congruent to anyone else. And finally, our four tick marks denote that segment CD is congruent to segment YZ or ZY. Likewise, the number of arcs show which angles are congruent. The single arc by angle A denotes that angle A is congruent to angle W, which also has a single arc. Angle B, the double arced angle, is congruent to angle X. Triple arcs mean that angle C is congruent to angle Y. And finally, the quadruple arcs denote that angle D is congruent to angle Z. So it appears that the second polygon is a rotation of the first or vice versa. So when we name the polygons, it may be helpful to start with your single arced angle and say that polygon beginning with angle A, then going to B, then C to D, is congruent to polygon W, X, Y, Z. Single arc, double, triple, and then quadruple. Two triangles are considered congruent if and only if their corresponding parts are congruent. That's a biconditional. If two triangles are congruent, then their corresponding parts are congruent. And if two triangles have corresponding parts that are congruent, then the triangles themselves are congruent. For triangles, we say that corresponding parts of congruent triangles are congruent, and it can be abbreviated as CPCTC. Likewise, we could just simply say that if we have congruent triangles, then we have congruent parts. All right, so let's work through one of these. We want to write a congruent statement for the triangles. In other words, we're trying to say that one triangle is congruent to another triangle. So we check out our first triangle and we see angle A has a single arc, and the other triangle on the right has an angle E with a single arc. Angle B has a double arc. The other triangle has an angle D with a double arc. Two pairs of angles are congruent so far. We can make a triple arc by this vertical angle at angle C and its vertical angle. We don't know that the angle at C is congruent to the angle at B or the angle at A, but we do know that vertical angles always have to be congruent. Then we know that the segment AB was congruent to segment DE based on the marks, the tick marks. And since AC has a length of 6 and CE has a length of 6, those two distances are the same. So double tick marks since singles were used. And finally, BC has a length of 4 and CD has a length of 4. So we can put triple tick marks at those two segments. Now we can name our two congruent triangles. There are 6 different ways you can name your first angle. You get to name it. But if I say triangle ABC, then I have to be careful to name the corresponding vertices in order. So if it's ABC, then I have to say triangle EDC. Because I started at the single arc, then the double, then the triple, and likewise single, double, triple. As I mentioned, there's 6 variations to this, so we could have started at triangle CBA, and if we say CBA, then we have to go CDE, etc. How you name the first impacts how the second must be named. In this next example, we are told that triangle RSV is congruent to triangle TVS, and we are asked to find the values of x and y. Triangle RSV is a right triangle. And angle R, because it's listed first, is congruent to angle T. We can put an arc, a single arc by angle R, and a single arc by angle T. That means that if we want to find the value of x, we must know the value of the measure of angle R. We also know that angle S has to be congruent to angle V. However, there's more than one angle at S. So angle RSV must be congruent to angle TVS. So a right angle at RSV means a right angle at TVS. And finally, angle V has to be congruent to angle S. Again, a second angle V and a second angle S, so angle RVS has to be congruent to angle TSV. So that tells us that TSV is 78 degrees. And we know from earlier that the interior angles of a triangle add to 180. If we have a right triangle, 90 degrees has been used of the 180, which means that 90 degrees is left. So if we take 90 degrees minus that 78 degrees, then we will have angle T. So if x is angle T, x has to be 12 degrees. Next, we can find the value of y. The value of y is determined by realizing that RS, segment RS, has to be congruent to segment TV because they have to be written in the correct order. Since RS and TV are congruent, 2y minus 1 has to equal 24. adding 1 to both sides of the equation to get a 0 pair. 2y is now equal to 25, and then dividing by 2, y becomes 12 and a half. 25 halves, or 12.5. All right, 2 other things to mention. We have properties of triangle congruence, and reflexive says for any triangle ABC, triangle ABC has to be congruent to itself. So reflexive is similar to a reflection in the mirror. When you look in the mirror, you see yourself. A triangle is congruent to itself, or a segment, SV is in both triangles, a segment is congruent to itself. An angle is congruent to itself if an angle happens to be in 2 separate triangles. So riffing off of the triangle ABC, we could say segment BC is congruent to segment BC. That's what reflexive means. Symmetric says that if 2 triangles are congruent to each other, we can switch the sides of the congruent sign. If triangle ABC is congruent to triangle DEF, then we can write triangle DEF is congruent to triangle ABC. The second becomes first and the first becomes second. And lastly, we have transitive, and transitive says if 2 triangles are congruent to each other and the second one is congruent to a third, then the first triangle has to be congruent to the third. Much like it's what worked when we were working with angle measures. Lastly, we want to note that if 2 angles of one triangle are congruent to 2 angles of another, because we're restricted to 180 degrees in a triangle, those third sides also have to be congruent to each other. So if we're trying to find the measure of angle P and we know nothing at all about angle P in this triangle, and we know only one other angle measure, I have an angle that is a 90-degree angle, it's a right triangle. If angle Q is congruent to angle C, and angle B has the arc to show that it is congruent to angle R, we can translate that 33 degrees to angle R, and because triangles, interior angles add to 180 degrees, and this is a right triangle, we've used 90, that leaves the other 2 acute angles to be complementary to each other. So 90 degrees minus 33 degrees gives us 57 degrees, which is the measure of angle P and the measure of angle A.